Welcome back to Sustainability Ventures, where we go beyond the headlines and break down the real risks and realities behind climate technology. Today, we're tackling a sensitive but critical topic. AI is transforming climate modeling, but what if the data powering these models is flawed? From predicting hurricanes to forecasting heat waves, AI climate systems are increasingly influencing government policy, insurance pricing, infrastructure design, and climate finance decisions. But here's the uncomfortable question. If the training data is biased, incomplete, or inaccurate, are we building climate policy on unstable foundations? Let's unpack it. For decades, climate forecasting relied on physics-based models developed by institutions like the Intergovernmental Panel on Climate Change and National Oceanic and Atmospheric Administration. These models simulate atmospheric chemistry, ocean currents, and greenhouse gas dynamics using physical equations. But recently, AI has entered the picture. Machine learning systems now predict extreme weather patterns, fill gaps in missing climate data, improve temperature forecasting, model flood and drought risk faster than traditional systems. Companies and research labs are even training neural networks on decades of satellite imagery and sensor data. AI doesn't replace physics models, it accelerates them. But here's the catch. AI is only as good as the data it learns from. AI climate models are trained on massive datasets, including satellite observations, historical temperature records, ocean buoy measurements, storm tracking archives, and emissions inventories. But climate data isn't evenly distributed across the planet. We have detailed, high-quality historical records from North America, Europe, and Japan, but far less comprehensive records from sub-Saharan Africa, small island nations, and remote mountainous regions. That imbalance creates a data bias, and AI systems tend to perform best where data is richest and worst where vulnerability is highest. Let's talk about the flaws. First, incomplete historical records. Many regions lack consistent weather station data before the 1980s. Second, urban bias. Most weather stations are near cities, meaning rural and agricultural patterns may be underrepresented. Third, sensor inconsistencies. Older instruments used different calibration methods than modern digital sensors. Fourth, missing extreme events. Some historical disasters weren't recorded with modern precision, especially in developing nations. Now, imagine feeding this into an AI system. AI identifies patterns, but if the dataset underrepresents certain regions or misrepresents historical baselines, the predictions may systematically underestimate risk. Here's the deeper issue. AI doesn't understand physics the way traditional climate equations do. It detects correlations. If historical data shows fewer recorded floods in a region, the model may predict lower flood probability. But what if floods were underreported or measurement tools were lacking? The AI can't distinguish between no data and no risk. This is known as data sparsity bias. And when AI outputs feed into infrastructure planning, climate risk insurance models, investment decisions, national adaptation strategies, even small biases can scale into billion-dollar misallocations. At the end of the day, AI climate modeling is not the enemy. In fact, it's one of the most powerful tools we have to accelerate adaptation and resilience, but we must be honest about its limitations. Better transparency in datasets, more investment in data collection in vulnerable regions, hybrid systems that combine AI with physics-based climate science, clear disclosure of model uncertainty in policy decisions. Because when AI guides climate policy, the quality of the data becomes a matter of public safety. So here's my question for you. Should governments require full transparency of AI climate training datasets before using them in national policy? If you found this breakdown valuable, hit like, subscribe, and share this with someone who believes AI automatically means accuracy. Because in the climate transition, data integrity is climate integrity.